Welcome to This Explainer. All right, I want you to picture something for a second. Imagine a fire that's just so impossibly huge and fueled by so much intense raw pressure that literally every single thing you know about putting it out is completely useless. We're talking about massive raging oil well fires here. And to defeat them, engineers use something that it sounds like it belongs in a wild Hollywood action movie, definitely not a standard safety manual. They use explosives. Seriously, they quite literally fight fire with a giant explosion. So, right off the bat, that begs a pretty incredible question, doesn't it? Why on earth would you use an explosion to put out a fire? I mean, just sit with that totally counterintuitive mystery for a second. Ever since we were little kids, we're taught that explosions cause fires, right? They spread them, they cause absolute destruction. So, how in the world could an explosion be the exact tool you need to extinguish a massive inferno? It's kind of the ultimate paradox. Well, to really wrap our heads around the solution, we've got to fully grasp the sheer terrifying scale of the problem. And it boils down to one thing: endless fuel. Look, we aren't talking about a burning wooden house where the timber eventually just turns to ash. Not even close. In an oil well blowout, you have highly pressurized fuel that is constantly, violently escaping straight up out of the ground. The earth itself is literally feeding the inferno. And because that fuel source basically never ever runs out, this fire it's practically immortal. It's just going to keep burning and burning for as long as that insane underground pressure keeps pushing oil to the surface. Now, faced with a raging blaze like this, our immediate human instinct is obviously to reach for water, right? Just douse it. But for a fire of this magnitude, one that's continuously fed by all that pressurized oil, pouring thousands upon thousands of liters of water on it does absolutely nothing. I mean, zero impact. It is completely, utterly ineffective. Actually, before it can even tame a tiny fraction of the flame, all that water just instantly vaporizes, or it simply gets blasted out of the way by the sheer physical pressure of the escaping oil. So that harsh reality forces a massive shift in our thinking. Traditional methods, like blasting endless streams of water, they're simply the wrong tool for the job. When our instinctive go-to solutions fail entirely against that immense pressure, engineers have to pivot to a really unconventional marvel, and that is the explosive shockwave. Now, to be clear, this isn't just about randomly blowing things up for the fun of it. It's an incredibly calculated, immediate disruption of the fire's entire environment. And that brings us to the formal name for this refined method, which is known as blast extinguishment. The main concepts to lock in on here are engineering technique and controlled explosion. Like I said, this isn't just tossing a few sticks of dynamite at a problem and keeping your fingers crossed. It is unbelievably precise. What happens is engineers strategically place specific explosives right near the base of this completely uncontrollable fire, all to trigger a highly controlled blast that is specifically designed to kill the flame. Okay, so how does the physics of this actually play out? Well, first, you set your explosives dangerously close to the raging fire. Then you trigger that perfectly controlled blast. But the real magic, the aha moment, happens in step 3. The explosion creates this massive, incredibly powerful shockwave, and that shockwave violently pushes away the burning gases, and this is the absolutely crucial part. It forcefully displaces all the oxygen surrounding the fire. By essentially breaking the fire triangle, or fire tetrahedron, depending on how technical you want to get, and removing that oxygen, combustion just instantly halts. The fire is literally choked out in a fraction of a second. It happens with just incredible suddenness. For just a single fleeting fraction of a second, that shockwave physically isolates the fuel from its oxygen supply. It pushes all the burning gases and breathable air far enough away to create a temporary vacuum. And in that tiny, momentary lapse of oxygen, this totally unstoppable, immortal inferno just dies. It's gone. It is such a breathtaking manipulation of physics, completely shutting down a massive force of nature in the absolute blink of an eye. It really makes you look at the world a bit differently, doesn't it? I mean, we took an explosion, a force we naturally, instinctually associate with pure destruction, and mathematically engineered it to stop a disaster in its tracks. It leaves us with a genuinely fascinating question. By manipulating physics, how else can engineers turn the ultimate forces of destruction into tools for salvation? It's definitely something to think about as you go about your day. Anyway, thank you so much for joining me for this explainer. Keep asking questions, keep learning, and I'll catch you in the next one.